Alright, this is part 2 of a review of proving triangles congruent. In this video, we will concentrate on how to tell whether triangles are congruent by angle, side, 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 angle, side, hypotenuse, leg, and we will go all the way to making two-column proofs proving that triangles are congruent and corresponding parts of congruent triangles are congruent. CPCTC. But first, problem number 11. What theorem or postulate can be used to justify that these two triangles are congruent? Well, in addition to what is already shown marked for us, we know that this shared side AC is going to be congruent to AC by the reflexive property. So if we look at all three pieces of information, we have angle, side. Okay? It's not going to be angle, side, angle, which is what you would get if you sort of went around the clock this way. Alright, you might say angle, side, angle. That would be wrong because if you're going to choose angle, side, angle, you need two angles with the side in between them. But here I have my two angles, and but this is the side in between them, not this one. So when you have two angles and the side that's not between them, that's when you call it angle, side. So that's why C is going to be the answer. Angle, side. Alright, similarly, look at number 12. On number 12, in addition to what we have marked congruent, we know that the vertical angles are congruent. So that's going to be side, angle, side. Okay, now we have to be a little bit extra careful because I see that we have two different answers using side, angle, side. So we have to be careful about the congruency statement and pick the one that has the correct congruency statement. So let's see. Let's look at the first one. A, B, C. Now, if we're going to talk about triangle ABC, okay, is congruent to triangle. Now, see how the markings are congruent diagonally. Okay, this side is congruent to this side. This side is congruent to this side. It's all about diagonal. So angle A is going to be corresponding with angle E. So 5 ABC, I'm going to start out with angle E on the other triangle. And then angle B is going to correspond with angle D. So if B is next, then I'm going to go D next. Okay, and that leaves angle C, which is going to be the same in both triangles. So another angle C here. So if I say ABC, then I have to say EDC. Okay, ABC, and they don't have EDC. Okay, so the answer is not going to be A, right? Because the congruency statement is wrong. Now, so let's look at this for C, and the answer really has to be C because that's the only one left with the side, angle, side. But let's look at it. If they say triangle BCA, so BCA is congruent to, okay, triangle. And again, angle B is going to correspond with angle D. So D should be first. And then C is going to be the same in both. So that'll be C will be next. And A corresponds with E. So A is last, so E should be last. Okay, so DCE. Let's look. And we do have D, C, E in the correct order. So that's why the answer is C. Alright, number 13. In triangle ABC, the measure angle A is 30 degrees and the measure angle C is 50 degrees. And we're given more information. Write a statement of congruence. Clearly we need to draw a picture. Alright, so here are two triangles that I just drew. Obviously this drawing will not be to scale. But we're given that angle A is 30 degrees. So let's fill that in. Angle C is 50 degrees. Alright, so with that information we could find angle B by subtracting these from 180. Well, 50 and 30 together make 80. So that means the other angle would have to be 100. Alright, so I'd have a total of 180. Okay, so moving on, angle E is 30. Okay, and angle F is 100. So you see the 30 and the 100, and that's 50 is left, so that means you can be guaranteed that this will be 50. So when we make our congruency statement, we need to make sure that all the angles match up properly according to their degrees. Okay, so if we start with ABC, for example, okay, so if I want to talk about triangle A, B, C, and I say that'll be congruent to triangle. Alright, so A is 30 degrees, so that's going to correspond with angle E, so that would have to come first. Next is B. B is 100 degrees. That corresponds with angle F, which is also 100. Okay, so we've done E and F, so that leaves D. But it makes sense because C is 50, which is last, and so D is 50, so it should be last. So triangle EFD is how that statement should end. Okay, and here's EFD right here. So that's why D is the answer. Whoa, slow down. We're not just making a congruency statement. Alright. Because first we have to decide, is there enough information to prove the triangles are congruent? So slow down. If the triangles were going to be definitely congruent in the first place, then yeah, that's the way they would have matched up. But I sort of wasted my time because the angle is not enough information. Okay, angle is not enough information to prove that two triangles are congruent. Alright, because for all I know, this triangle could be smaller and this triangle could be bigger. Alright, and it could still have your 50 degrees and your 30 degrees and your 100 degrees. Okay, so you could still have a big triangle and a small triangle, so they wouldn't necessarily be congruent. So for that reason, we have to go with A as the answer. Okay, so wasted a little bit of time there. Let's go on to number 14. UT is a mid-segment, so we're supposed to find SQ. Alright, but you can bet we're going to start by finding x, and then we'll figure out SQ after that. So when you have a mid-segment type situation, alright, if this is the mid-segment, and this is the side that it's parallel to, then we know that this larger side is going to be double the mid-segment. So for example, if this was 10, then this would be 20, just as an example. Okay, so when we go to make an equation, what we need to do is to double this one. Okay, if I were to double this, then it should equal that one. Alright, so in other words, okay, if I go double 3x plus 1, okay, double the small one, that should equal the larger one. So that's going to give me 6x plus 2, and that should equal 7x minus 1. Alright, so let's get these variables together. So I'm going to subtract 6x from both sides. So that's going to give me 2 equals x minus 1. Alright, and then we'd add 1 to both sides. So that's going to give me 3 is equal to x. Alright, so now I know that x is 3. So, what I could do is I could take that 3 and substitute it in for the variables. So that's going to make this 2 times 3 plus 2. So that's going to be 6 plus 2. So that's going to be 8. Okay, but if this is the mid-segment, that means this is a midpoint. So that means these two sides are congruent to each other. So if this SU is 8, then that means UQ is also 8, which means that the total distance from S to Q is going to be 16. Okay, the total SQ is a total of 16. And that's what we were supposed to find. So that's why the answer is C. Alright, so for number 15, we're supposed to make a 2-column proof. Given this information, we're supposed to prove that angle W is congruent to angle Y. Alright, these two are congruent. And our strategy will be, first let's prove that the triangles themselves are congruent. If we can prove that, then W and Y will be corresponding parts of congruent triangles, and so those will be congruent. So let's see why the triangles are congruent. Well, looking at the markings that we already have, plus the shared side, ZX is going to be congruent to ZX by the reflexive property, then the triangles are congruent by the side-side-side postulate. So that's what we're going to do first, is state that the triangles are congruent by the side-side-side postulate, and then W and Y will be congruent because corresponding parts of congruent triangles are congruent. Alright, so let's just write that all out, and so that looks like it's going to take 5 steps. Alright, depending on if I wanted to say the given all at once. Alright, so we're going to make our 2-column proof, statements, reasons, and if I know I'm going to prove the triangles congruent by side, 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 I like to organize my work to break it down as side, 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 one on each line. You could probably get away with combining all the given into one, but this helps me make sure I don't miss anything. So I'm going to do it this way. So my first side, for example, I might say that Wx is congruent to Zy. Okay, so Wx, hold on. Wx is congruent to Zy. Okay, that's given. Okay, and I might say that Wz is congruent to xy. Okay. That's also given. Okay. Now that leaves the shared side Zx. So I could say Zx is congruent to Zx by the reflexive property. Alright, so obviously you didn't have to say it exactly like I did with the Wx and the Zy. You could have said Wx and xy, alright, for example, but basically I'm stating the, I'm getting the given out of the way with these 4 markings. Okay? Now, I've shown a side, and a side to be congruent for both triangles. So now that I have that, I can go ahead and say that the entire triangle is congruent to one to the other. So for example, I could say that triangle ZWX alright, is congruent to triangle ZYX. Whoops. And of course we knew that we would say that by the side, side, side postulate. Okay, now that the entire triangle is congruent to the other triangle, we can focus on this one pair of corresponding parts. And we can say that angle W is congruent to angle Y because corresponding parts of congruent triangles are congruent. So that is your 2-column proof. Alright, for number 16 we're supposed to make another 2-column proof. So let's get our strategy together before we get started. We're given that M is the midpoint. Alright, so that's fine. So by the definition of midpoint, that means that, well, okay, M is the midpoint of both segments, okay, RS and PQ. So by the definition of midpoint, that means RM is going to be congruent to MS, and PM is going to be congruent to MQ. In addition to that, we also see that vertical angles are showing, so vertical angles are always congruent. So we can know that these two triangles will be congruent by the side angle side postulate. So we're going to be shooting for side angle side. And now, if the triangles are congruent, then we can pick any pair of corresponding parts. So QR and PS would be corresponding parts. And of course, corresponding parts of congruent triangles are congruent. So let's see, I'm trying to estimate how many steps this is going to be. Okay, so the given does not directly say any of these pieces, so I'm going to need one line for the, maybe I'll just number them as I go. I'm going to need one line for the given, and then I'm going to have my three pieces. So I'm going to need my side, my angle, and my side. And then the triangles are going to be congruent, and then CP, CTC. Okay, so that's 1, 2, 3, 4, 5, 6. Alright, I'm going to need 6 lines. Okay, so here we go. First, we're going to state the given. M is the midpoint. Okay, I'm just going to write this down off camera. M is the midpoint of PQ and RS. That is given. Okay, now if my strategy is to prove these two triangles are congruent, and we know this is going to be side, angle, side, then I like to organize my work by saying, stating a side, a pair of sides, a pair of angles, and a pair of sides. I sort of keep it in order like that. The order is not actually important, but it's just an organization. So, pair of sides. Okay, I'll do these two first. So, RM is congruent to MS. Okay, we knew these would be congruent because this was the midpoint, and that's the definition of midpoint. So that's the reason, is definition of midpoint. Okay, so we're doing side, angle, side. So it's time for some angles. The angles are these here in green. So that's angle PMS. Alright, is congruent to angle QMR. Okay, do not say angle M is congruent to angle M. Alright, you can't call, it's not the same angle, so you can't call two different angles the same name. So you have to use the three-letter designation. Anyway, we knew those would be congruent because of the vertical angle theorem. Or you could just say vertical angles are congruent. Or you could say vertical angle theorem. It's up to you. So I've done a pair of sides, a pair of angles. Now it's time for another pair of sides. So I'll do the double marked ones now. So PM is congruent to MQ. Okay, and again, that's definition of midpoint. Alright, so now that we've shown a pair of sides, a pair of angles, and a pair of sides congruent, the included angle, then I know that the triangles will be congruent by side, angle, side. So it's time to go ahead and make the congruent statement. So I could say triangle PMS is congruent to triangle, and you have to be careful the order. If I say PMS, then I have to say QMR. And of course that is by side, angle, side postulate. Okay? And once you have proven that the whole triangles are congruent, then you can focus on any pair of corresponding parts you want. And of course, your last statement has to be the thing that you're trying to prove. So QR, segment QR is congruent to segment PS because corresponding parts of congruent triangles are congruent. Alright, so that is your two-column proof. Alright, that's going to be a good place to stop this video. Alright, this is part 2 of a larger review. Let's take a sneak peek and see what is in store for the third and final part of this review. Okay, so we have a couple more two-column proofs coming up in part 3. And anything else? Alright, a little discussion about constructions. And specifically we're going to learn how to know what kind of construction was done just by looking at the markings. Okay? Oh, and then a probability review problem. Alright, so I will see you on the next video. We have one more part of this review still left to come.